Here is my list of functions followed by my list of derivatives. Find me the pattern. What can you tell me about the pattern? The powers are one less. Let's state that for a fact. The powers are one less. That's a guarantee. Noticing that the 3 becomes a 2, and the 1 becomes x to 0, which we know is 1, right? What happened here, though? We got x to the first here. No, we don't. We have x to 0. So that's interesting. But we agree the powers go down, or one less. What else you got for me? Let's take a look at this one in particular right here. Take a look at this one and this one right here. These are two that are important. Right? Let's take a look at those two. Tell me what I got going there.
There's no pattern. You're crazy. There's a pattern.
Let me ask you a question. It's a strange question. Where did this 3 come from? Okay, guys. Teaching here. Thank you. So, 3. Where does 3 come from? Where did the 3 come from? Any ideas? No ideas? Do you see a 3 in the original expression? In the power. So the 3 did what? The 3 became a 2 and then went out in front. Is that right? Let's take a look at our pattern here. If that's true, why is this a 4? Added together? It's a fair, reasonable approximation. Then why is this 0? They multiply together. Now let's check your thing. You're going to multiply by the power. And actually, I'm going to take this and write it after. Power is 1 less. So let's take a look, see if this makes any sense at all. So this is x to 0. 0 times 3 is 0. Boom. Power goes down by 1. Doesn't matter because it's 0, right? This is x to the 1. Bring it down, comes x to the -5th. This becomes x to the 0, which is 1 and goes away, right? Your pattern's working so far. If I put a 1 here, I throw this out in front, I get 5/3. X to the 0, which goes away. What happened to this? As an x to the 0, when I multiply by 0, it goes away, right? What about this one? The 2 goes down, multiplies, makes the 4. Power goes down by 1. This one has no number in front, but there's a little 1 there, so I throw the 1 out in front, and then write x to the 0, which is 1, goes away. And this thing has x to 0 on it, so it becomes x to, so it goes away, right? When I multiply by 0. Is it working? So this is how, this is called the power rule. Okay? Actually, the very first way in which calculus was discovered. Isaac Newton came up with that and then had to figure out how to prove it worked because he couldn't figure out why. He just knew it did. We've now gone the other route. We went through the Proofian to get to the how it works. I'm not going to do much with the formal definition. On your test, one time I'm going to make you go through the painful process of using it. Okay? The power rule doesn't solve every problem. I know a bunch of problems it doesn't solve, so I can mess with you. I'll tell you the power rule won't work in this case, so do it the hard way, and then I'll do it the hard way. But for purposes of the AP Central and the test, the one thing it's going to be able to do with the formal rule is do what? Recognize it, know it's the derivative they want you to take, and then do the derivative a different way. Okay? That's what's going to happen on the test. You're going to look at it and go, oh, that's the formal definition of derivative. I'm going to do it a different way. I'm going to do it one of the ways we've learned later on in class. Okay, so we multiply it by the power of 1 less. Okay, so here's what we're going to do here. So I'm going to ask you to do the following. The very bottom of this page, it has some instructions. Instructions are, first of all, what is the derivative, and, using the power rule, and the formal definition. It is for your best interest that you do it the formal definition way, but given the constraints of time right now, we're just going to go ahead and jump ahead and say f of x equals x cubed minus 2x squared minus 5. What would be the derivative of this function?
2, 3x squared. Yes, more. Minus.
Very bottom of this page.
4x. Yep. That was dark. What happens to 5? It dies. It just, oh, that's right.
It'll be an x to 0, so it'd be 0 times that.
Oh, okay.
Now, as you get good at these, you're not going to do it the way I'm about to do this problem. As you get good at this, you're not going to do it with the same slowness I'm about to do this problem, but I'm going to actually show you, make sure. First thing I notice, if this thing's missing an x, I rewrite that as x to the 0, right? So remember, there is a power on that polynomial. Remember, any variable to 0 is what? 1. So now I go ahead and get ready to do this. I bring down this thing in front, ka-chunk, 3x, bring this down by 1 to the second power. Multiply 2 times 2, I get negative 4x, drop its power by 1. Bring this down, I get negative 0, x to the negative 1, which doesn't matter because 0 times anything is 0, so that goes away. And so my derivative would be 3x squared minus 4x done.
I do all the math to check.
Now, you have the ability now to check using the formal definition to do it. You'll do that as your own time, part of your homework, and for your own moral edification. Flipping this over, I want you to start with problem number 3. Start with problem number 3. You actually can do 1 and 2 in your sleep right now, but the purpose of this lesson is to start. I'd like to do 1 and 2. I got 7 minutes, so I'm going to jump towards 3. Start doing 3, 5, 7, 9. 4, 6, 8. Start doing all those. Go.
I'm so happy. It's so easy. I've never been so happy in my life.
Doing calculus, doing derivatives.
This is great.
This is one of those moments when I say doing calculus is actually easier than doing algebra 2 or trigonometry.
I'm so happy. I mean, look at it. So wait, one over. Wait, what do you do with 1 over x8 though? Is it 0? What? 1 over x to the 8th? Is that 0?
1 over x to the 8th.
Number 8.
1 over x to the 8th. So you write x to the negative 8, right?
Sure.
Right, because you know 1 over x to the 8 is that. And then you pull the negative out in front, drop its power by 1.
So it'd be 0.
No.
I don't understand. Yes.
Okay, folks, another notation. If I give you y, the derivative can be written as y prime, which would be this case 0, right? Because the x is 0, pop it out in front. That's what we cancel out. 5. Y equals x to the 6th. I get y prime is therefore equal to x to the, 6x to the 5th. 7. y equals 1 over x to the 7th. Now, some of you start to panic. You need to start to lock up. You're supposed to remember, because I beat it into you extra special last year, that can be also written this way, right? And so then I'm going to use the same rule. Y prime equals, pull the negative 7 out in front. Now, this is something that's going to, some of you are just going to struggle with all year long. What is subtracting 1 from negative 7? Negative 8.
Yeah.
I don't know why that is, but I got to tell you, that one gets a lot of people. And you know better. Every time you go, oh, yeah. Should have known that one.